ratio, proportion, and variation problems. Okay. So, the proportion A is to B equal to C is to D means that A over B is equal to C over D, where A and B are called the extremes while B and C are called the means. Then we have the relationship between the proportion of 2, 3 numbers, 4 numbers, no? 2 or 3 or 4 numbers. So we have here, if A is to B, A is to X equal to X is to B, then X is called the mean proportional to A and B. Then if we have A is to B equal to B is to X, then X is called the third proportional to A and B. Then if you have A is to B equal to C is to X, then X is called the fourth proportional to A, B, and C. Okay. So to illustrate, we have problem 1. So find the fourth proportional to 15, 77, and 90. So we have 3 numbers there, and then we look for the fourth number, which is the fourth proportional to the 3 numbers. Now, so arranging the numbers, we write it 15, 77, 90, and we have the last number x, which is the fourth proportional to the 3. So by proportion, this is equal to 15 over 77 equal to 90 over x. And we can solve for x equal to 462. Okay? Then problem number 2. 2/3 of people in a party are lawyers whose average IQ is 120. The rest are engineers whose IQ is 180. What is the average IQ of all persons in the room? Okay. So, we will let X equal to the total people in the room. And then, the population of the lawyers is 2/3, huh? And the population of the engineers is 1/3 of X. Okay. So, we will start with the average IQ of the lawyers, which is given, huh? So, the average IQ of the lawyers is equal to the sum of the IQ of the lawyers divided by the total number of lawyers. And the average IQ is given as 120. And that is equal to the sum of the IQ of the lawyers divided by the total lawyers, which is 2/3 of X. So we can express the sum of the IQ of the lawyers in terms of X, and that is equal to 80X. Then we have the average IQ of the engineers, which is equal to the sum of the IQ of engineers divided by the total engineers. And that is given, the average IQ equal to 180. So equal to the sum of the IQ of engineers divided by 1/3 of X, the population of the engineers. So I can solve for the sum of the IQ of engineers, and that is equal to 60X. And then I can have the IQ or average IQ of all persons. So that is equal to the sum of the IQ of the lawyers plus the sum of the IQ of the engineers divided by the total persons. So, we have now the sum of the average IQ of the lawyers, 80X. For the engineers, 60X. Then the total persons is X. So, we can cancel out X. And the average IQ of all persons is equal to 140. Next problem, here. An 18 feet long pipe is to be cut into 3 parts in the ratio 2:3:7. Find the length of the shortest part. Okay. So, 18 feet long pipe cut into 3 parts in this ratio 2:3:7. Okay. So, we can represent the 3 parts now. So, let X equal to the shortest part, Y as the second part, Z as the third part or the longest part. Okay. So, the proportion or the 3 parts, X, Y, Z, also follows this, or follows this proportion. So, we have here, X is to Y is to Z equal to 2:3:7. And we can use the proportion of x and y first, no? So we have the proportion x over y, that is also equal to 2 over 3. And from this, we can express y in terms of x, and y is equal to 3 halves of x. So we now express y in terms of x, no? We will do the same for z. So express z in terms of x, so we have the proportion for x is to z. And that is equal to 2 is to 7. So we have that here, no? So x over z equal to 2 over 7, and we can express z in terms of x. And that is equal to 7 halves of x. Second equation. Then what shall we do? We can substitute the second and third equation, or first and second equation, to the third. So if we add up the three parts, that is equal to the total parts, which is 18. Then we can substitute y and z to this third equation, so that the only unknown here is x. So we have here, no? So x plus 3 halves x, which is the y, plus 7 halves of x, which is the z, and that is equal to 18. So from this, we can solve for x, that is equal to 3 feet. Okay. So another way of solving, another approach is this, na? Let x equal to 1 part of the proportion, and then following the ratio, so we have 2x is the shortest part, 3x is the second part, and then 7x as the third part, or the longest part. So the total parts is equal to 12x, na? And this 12x is equal to the total length of the pipe, which is 18. So from this, we can solve for x, and that is equal to 1.5 feet. So this x is not the x here, because x here is 1 part of the proportion. And since the shortest part is equal to 2x, so the shortest part equal to 2x, that is equal to 2 times 1.5, or that is also 3 feet. So we arrive with the same answer. So sometimes a problem situation involving ratio proportion, it is easier to solve this approach. Sometimes it is easier to use the first approach. So depende lang yan sa inyo, no? Depende rin sa problem situation kung anong medyo mas dali niyong gamitin. Okay. We have here variation problems. So we have the types of variation. So if z varies directly as x, then we write z equal to kx. And if z varies inversely as y, then we write z equal to k over y. Or we have z equal to k times 1 over y. Then the third is the combination of 1 and 2. So we have the joint or mixed variation. So z varies jointly as x and y. So we can write z equal to kxy, where k is still the proportionality constant. Okay. So to illustrate, we have here the problem. The weight that can be safely supported by a beam with rectangular cross-section varies directly as the product of the width and the square of the depth of the cross-section, and inversely as the length of the beam. If a 2 inches by 4 inches beam that is 8 feet long can safely support a weight of 500 pounds, find the weight that is safely supported by a 2 inches